Welcome back, everyone, to an AVS Tech Talk. Super excited to have a special guest today. It's way overdue. I've worked with Kenyon for some time, one of the sharpest networking minds I know of in the industry. To kind of pump you up already, Kenyon, you want to do a quick intro of who you are, what your role is?
Sure. So my name is Kenyon, right? I'm a principal technical program manager here at Microsoft. I work in the AVS product group. I've been here for maybe 4 years now. Previously, I was at VMware in both the NSBU and the core teams, selling all kinds of VMware solutions across the US.
Yeah, lots of NSX and NSXT, right? Which is
yes,
obviously a
yes.
huge piece of AVS and something that's new to a lot, not a ton, but customers come into AVS getting used to software-defined networking along with other cloud components. Yeah, so you're here to tell me all the content we've created on this channel is irrelevant
Pretty much.
because
Yep.
there's big changes, right? This we're now in generation 2, which is kind of funny because it's kind of like generation 3. Maybe we touch on that for some of the newer people. Were you around during the CloudSimple days, or maybe bring us through the journey of AVS and how, like, what generation 2 even means in the timeline?
Sure. So I showed up shortly after CloudSimple was acquired by Google. And so
Mm,
CloudSimple had done some work inside of Microsoft. And we, in fact, had CloudSimple clouds still hanging around while I was here.
yeah.
There was a big migration that went to AVS, which was based on some Virtustream IP. Um,
Mm,
and so that migration involved a lot of funness around HCX because like CloudSimple supported VLAN back networking and overlay back networking and a host of other options.
yeah.
Yeah, it was pretty cool, but Google bought them, so it had to move on.
Yeah.
And then that migration to what we call Gen 1 today, which had just been the AVS product for some time. That was like the thing that everyone is used to today, right? It's the Express Route connected Dell hosts with maybe some AV64 sprinkled in here or there.
Yeah.
And so that initial AV64 sprinkling in, we called it hybrid or just AV64 clouds, right? That was the first kind of foray into what we're talking about here on Gen 2,
Yeah. I mean,
which
just,
was the big
this
step.
is the power of cloud, right? Like iterative changes constantly. It's almost even hard to delineate Gen 2. I think Gen 2, and this is, definitely like where we're getting into the networking piece of it. There's networking changes, like you mentioned, between the express route and not, but Gen 2 is also hardware, right? So like
Yes,
AV64s, maybe like you mentioned, the first generation was Dell hardware, which is always fun. You can go into vCenter, it tells you the hardware that's being used, right? It's right there. It tells
absolutely.
you Intel CPUs, the manufacturer. So some people are thinking Gen T is just networking, but it's also fleet hardware only, right?
Yes, absolutely. And that's the interesting part, right? So when we looked at hybrid, um, we see that we have to have a 3-node Dell cluster to begin with,
Yeah.
which provides all the north-south connectivity options. And then when we're moving to Gen 2, we're removing that option. That's kind of the big fancy new thing.
Yeah. Which is so much simpler too. Like I think one of the highest hits that I get on my blog is actually the sizer, which you need to have because you had to have some way to calculate what's this 3-node capacity versus the additional capacity because that goes into sizing and what do I host on it. So like this is going to be a big, massive shift to fleet hardware, so capacity, which is really exciting, and new node types, more modern CPUs. But also just simplicity. And if you want to do a single cluster,
Yeah, absolutely.
like the two top. Well, let's, I know the number one thing that people are interested in, or at least I'm interested in, is the networking, because by far, if I were to really oversimplify complexity of some of the cloud stuff is moving to a new networking model, right? Like, it's no longer your own physical network devices. You need to understand networking objects and how they connect. And once you kind of piece that together, you start to realize how you can build these services for your company. So maybe walk us through like a quick summary of what AVS Gen 1 networking was, and then where we're going into like this Gen 2 networking.
Sure. Just load up this slide here.
Yeah.
And so this is Gen 1 networking, right? So we have a connection from AVS via this DMSE or this dedicated Microsoft Enterprise Edge device, which is how we connect AVS into Azure. And it's the exact same way that customers connect their on-premises locations today via ExpressRoute. And so this express route construct, because we weren't running on Fleet hardware, we didn't have native VNet integration. We had to use this special connectivity pattern that introduced a lot of problems. So I'm sure if anybody who's gone through and looked at all the different networking scenarios on Gen 1, you've seen some crazy things that we've had to do with like Azure Route Server, multiple peered VNets, multiple route servers, multiple MVAs, all kinds of tunneling. All of that is kind of a byproduct of having to have this express route. And then having the connectivity options that we had there around having either through VNets, through MVAs, or through global reach, all of those things are just not normal patterns, and they have a bunch of limitations that are hard to understand and then very complex to configure the workarounds for these things. And that
Yeah, I think
was,
it's hard to
yeah,
summarize that. Like I even remember working with a customer and we were doing pre-recs and we told him, hey, you need the /22 for the AVS service. And he went and provisioned an AV /22 VNet. And I was like, no, 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 no. Like it's in the service deployment. So like, it is kind of like it's in the cloud. And some of the cloud people that have been working at Microsoft, like, oh, it should work this way, but it wasn't, to your point. It's like
yeah,
it was
exactly.
express route connected just because of the way it was in a different, you know, part of the data center is best way to describe it, with its different enterprise edge routers.
Yep, exactly. It's really complex.
Yeah.
And so, what we've done now, let me just move to the next slide here. We've removed that problem, right? So in Gen 2, the big thing, and it may not seem like a big thing to a lot of people, but to us it was massive,
Yeah.
is the integration of AV64 nodes running ESX directly attached to VNets. So
Mm-hmm.
like the physical interfaces that come out of the back of these hosts now are already plumbed into VNets. There's no extra devices in path. You just get direct into the Azure SDN, and you can have a new VNet, and you set up its IP space, and we consume that. And then we can have AVS act like a regular spoke in your traditional hub spoke infrastructure in Azure. Um, it acts like a normal Azure service now. I mean, for the most part. I mean, under the hood, no, but as far as consuming, it's very, very simple now.
Yeah, an object just like a Azure VM, like truly like an Azure VM or a managed database or a service, like all those things now look and feel identical versus kind of
Right.
like off to the side,
Yeah.
still in Azure, still low latency, but different networking components. And so, like, what does that mean for a customer? Because like I haven't deployed one or seen, I think I've seen one of these, but I'm always curious, especially because this product's growing rapidly. So pre-recs are usually one of the things we cover on these channels. So do they go and provision the VNet and the subnets? What's kind of like the highest level when I'm prepping for networking for AVS? What do they have to go do that's different?
So you go make a VNet and you
Mhm.
give it the address space of the /22, and then you go deploy your cloud. Right? You
Oh, that's
point
slick.
it at the VNet and off it goes.
So it makes all the subnets
Yep.
independently for like vMotion, because we've got all these things that we're used as VMware users, like these dedicated networks for different services, and then you have your front end connectivity.
Mhm.
Okay, that's
And so
slick.
you'll see a lot of those networks show up now with subnets, right? So there's the ESX management interface. That subnet shows up. There's the NSX uplink interfaces. They show up. The
Mhm.
vSAN, the vMotion, all those things start showing up in the portal as subnets. Now you don't actually see the NICs or anything, right? We have taken those out of the customer subscriptions, but or you see the subnets. And what's interesting is you can now apply policy to those subnets like NSGs or route tables directly.
Yeah,
Yeah,
that's
so
that's huge. Yeah.
we've had, people ask about how to do, like, how do I filter traffic just for vCenter to only come from specific management networks? Well, before it was do all this funky stuff and you might get there and it's a lot of work.
Yeah.
And now it's just apply an NSG to that subnet and you can do whatever you want to with it.
Yeah, to your point on the I mean, the credit to Microsoft and Microsoft Docs, and I love the fact it's housed on GitHub and can take incoming requests. There it was complex, but at least there was great designs to follow, right?
Mhm.
Like your point around separating the management for a lot of enterprises, no user should be able to hit the vCenter interface, right? Like
Exactly.
that shouldn't be possible. And there were ways to do it, but it required that transit network you had to create, which included just another hop in the path. And like you said, there's the Azure route server that you'd have to do. I mean, this is like a massive, it's like, to your point, massive enablement to existing Azure services. The NSG's piece is actually one I hadn't thought of. That's pretty exciting.
Same thing for route tables. Like if you have different paths that you want traffic to take based on the type of traffic it is, you can forward that around wherever you want. We've also protected some of those objects. So like we have a network intent that ensures that the SDDC keeps functioning, because some of those networks, like they need to work to each other to allow the SDDC to work, right? And so we have a policy that's applied that doesn't allow end users to violate the predefined policy, but anything else they can change. So
Yeah,
it's
can't cut yourself off from a network
exactly. Well,
perspective, which we've all done at some point in our careers.
yes.
Yeah.
Oops, I just blocked access to vCenter with NSX. Never done that
Yeah.
before. No.
Yeah, I was going to go there with some sort of SDN level component. Makes it even easier to do that for sure.
Yeah. Yeah. And so
Very cool.
that's like the big thing, right? Is this network. But we also get some other interesting things that show up with this. On the new architecture, instead of just the 2 NSX edges that we're used to in Gen 1, now we can have 4. So your SDDC by default comes with 3. And as you scale up to another node, up to 4 nodes in cluster 1, you'll get an additional edge. And so now you have way more ingress egress bandwidth availability in your cloud.
Yeah, and that's a good point. It's another thing I hadn't thought of too, because I remember in like VDI situations, we would get connection limit throttled because of the number of edge nodes that we had, and so that enables even larger installs for VDI workloads if people are looking at things like that, where or even VMware server workloads that are just highly dense, right? Not everyone's as dense as that needs that kind of capability, and I'm sure it also helps with throughput and other things along those lines.
Yeah, and there's no additional hops, so latency goes down as well. And in the new subnet design, we also laid some groundwork for larger host management interface subnets. So like previously, we were really limited on scale of SDDCs by the subnet sizes and by multiple uses of the subnets by different services. And so now we've isolated everything to its own subnets and allow for many more hosts to be in the subnets in question. So, right, theoretically, it's possible to have a much larger SDDC at this point.
Okay, that's good. So is there some flexibility on the size of the subnets themselves? Like, is it more dynamically sized? So if for example, it was just a flat /22, can I do smaller networks if I know if I have a smaller cluster, or is it only up?
No,
Really?
it's
Yeah.
required for the 22 because we break it up into a certain amount of subnets.
Yeah, that makes sense. Okay. Well, so let's shift for people that are on Gen 1, and what this means to them. Microsoft has worked with customers all on brownfield installs. Microsoft's been doing this for a long time, of making sure that existing customers are being served while there's a new generation of technology coming in place. So like, what do Gen 1 customers need to be thinking about with their existing investments? Like, should they be thinking about growing into Gen 2? Maybe they say on Gen 1 and HCX over to Gen 2. What should they be thinking, both from existing brownfield installs and what they do next as they grow?
Sure. So we're going to keep Gen 1 around for some time, right? There are no plans for deprecation of Gen 1. So
Okay.
it will be around and you can continue to operate on it. In fact, for consumers of the public IP on NSX, right, it's not supported on Gen 2 right now. So you will remain there. Things to look at for moving to Gen 2 are host sizes, and host SKUs are a little bit different. You do have, like you mentioned earlier, much more modern CPU architectures. So we have some customers who on-prem have newer CPUs than we have on the Dell hardware.
Yeah.
And that becomes a problem for things like HCX migrations. And so this is a great way, if Ice Lake is what your target is, we have that in AV64 today. If you wanted to move today, HCX would be the way to do it. And it would be just like a regular move from an on-prem location to AVS, except now you're already in the cloud. So the throughput limitations are generally gone. We can migrate much faster. And because it's essentially the same service, there's probably not quite as many migration headaches as you would have run into coming from Microsoft.
Yeah, layer two extensions should get some pretty good throughput.
Yeah.
It's even to like you could actually start getting into the considerations of scaling out your network extensions to support the amount of throughput. They'll be the limitation versus the actual link, which was for a lot of customers I worked with, especially moving from on-prem into the cloud. That's a good point.
Yeah,
Yeah.
so like if you look at the throughput between the clouds, like from a Gen 1 to a Gen 2, it is essentially the host interfaces on the Dell hardware that are the limiting factors. So it's a 25 gig interface because the AV64 nodes all have 100 gig interfaces, and the express routes, there's no rate limiting there at all. If you do have things like a VNet gateway in path, it may be your limitation, but you can enable fastpath on those and just completely bypass that.
Oh,
So
yeah. That's
like
good.
the only limitation is that Dell interface of 25 gig.
Yeah. Man, I'm just thinking, we want to keep these short, but even just enablement of like, backup VNets and connectivity to those and restores.
Oh yeah.
Some really cool designs when I was working on the AVS team around like cyber resilience of like, backing up, how fast can I restore an SDDC? And that is a right and an intensive throughput thing. So it's
Hmm.
like I could see that getting shaved down.
Yeah.
That's really exciting.
And I guess another thing on that, we've moved to ESA for Gen 2. So you'll get far better
Oh,
read and write performance on vSAN too. It
yeah.
performs dramatically better than the Gen 1 clouds do.
Yeah, and then the AV64, if I'm not mistaken, was all NVMe end to end
Correct.
too.
It
So
is.
like, which that makes sense because the ESA is only NVMe, so that those go kind of side by side. Versus the AV36s did have actually SAS SSDs,
It
if I'm
did,
not
yes.
mistaken. So
Yeah.
again, it's like everyone thinks about the CPU types, which are really important. Like every generation brings certain things, but storage performance makes a big difference, especially in specific use cases. It's not the days of flash have changed things, but there's still these things like cyber resilience that really press how fast we can recover and things of that nature.
Yeah.
Well, very cool, man. I'm excited. I know this has been one of the worst kept secrets at Microsoft, right? Like everyone's been, this is like it's poor framing, and the reason why I'm not marketing is like this is the networking you wanted, right? Like
Yes.
I mean,
Yes,
it
it is.
really is.
Yes.
It takes a lot of work though, and it shows Microsoft's listening to their customers on where they want to get to, and man, it's going to simplify a lot of transitions. So I'm super excited. I'm glad you took the time to speak to us today, and hopefully, happy ventures on the transition. If anyone has an idea for another tech talk, feel free to reach out to me on LinkedIn. You can also find Kenyon. He has a blog. If I'm not V Ski Ball, is that
That's
what it's
correct. Yep.
called?
Yep.
Yeah.
Deep people.
Some really slick NSX stuff I learned on there too. So definitely go check that out. But appreciate everyone's time. We'll see you on the next video.